Hello guys, today we will be talking about your 8th lab. In this lab, we will be designing a simple calculator. Our simple calculator will have 6 different operations. These are multiplication, addition, subtraction, taking the power by 2, incrementing by 2, and decrementing by 2. This design will have 2 inputs called data in and valid in. We will talk about these inputs later. And we should also say that your output will be a single output called data out. So for this design, you're going to design a state machine. This state machine will either execute in 2 states or 3 states based on your operation. Now, let's take a look at our block design. Here you can see our block design and our inputs and outputs. So on the input side, we have reset, clock, valid in, data in. So reset and clock should be obvious to you by now. They are the same as the previous labs. The valid in input is your confirmation button. So it is a single bit input, so we can use it as a button. So you use this button when you want to confirm that you have made an entry. We will go into more detail when we're talking about examples. And then here we have data in input. This data in input is an 8-bit input given by the switches on your FPGA. And then finally we have our output data out. This is represented by the LEDs on your FPGA. So now let's take a look at our design behavior. So as we've discussed, we have the following operations here. So each operation has a corresponding number to it. So multiplication operation has the number 0 corresponded to it. Addition is 1, subtraction is 2, and so on and so forth. Now, there is an important distinction to make here. You see, these 3 operations take in 2 numbers. So in order to multiplication, you would need a number and then another number. For addition, number and another number. Same for the subtraction. But when taking a square, you need only one number. And same for decrementing and incrementing. So this is why some operations take 2 states while the others take 3 states. Now, in order to understand our design better, let's take a look at our state machine. Here we have our state diagram. Here we can see the inputs valid in and data out. So, for example, here is the initial state. So, in the initial state, you should wait for your number. The user should enter their number and then press the valid in button. So, how do we read this from here? While valid in is 0, your data out is 0. So you should see 0. So all the LEDs should be turned off on the FPGA. They should keep going until your valid in is 1. So this should be 1. There's a mistake here. So when valid in is 1, your data out should be equal to the number. So this number here is your data in. So the user entered the number through the switches, and your data out, your LEDs should show this when you press the valid in button. Also, another thing to know is that you should store this data in because you will be using it on your later states. So here it is shown as number equals data in. So data in has been stored in number. Okay, now let's go back and look at, let's go forward and look at the next state. So here in the S1 state, you can see that while valid in is 0, meaning that while the button is not pressed, your data out should be equal to number. So same as here, your data out should be the number that you entered in your S0 state. And then when you press your valid in button, two things can happen. You can either go back to S0 or S2. Now this depends on which operation is chosen. So in order to choose an operation, the user should enter a value through the switches. So as we've discussed before, each operation has a corresponding number. So if I wanted to do multiplication, I should enter 0 from the switches and then press valid in. So if we did multiplication, this would be true because operation would be equal to 0. In this case, your data out, meaning that the LEDs on your FPGA, should be equal to the operation. So for multiplication, that would be 0. But if you choose one of these 3, 4, or 5, meaning that square, increment, or decrement operations, you're going to go back to your S0 state. Why? Because we don't need to get another number. We can simply give out the result. So what we see here is the data out, meaning your LEDs should be equal to your result. So in here, you should calculate your result and then put it in your data out. And then let's go to your S2 state. So let's remember that S2 state is when you're using one of these operations, 0, 1, or 2, meaning that it is an operation taking two numbers. So again, another thing to note is that you should store your operation, meaning that you should store the data in value that you entered here in a variable which could be called operation because it will be used in the next state. So in the S2 state, while the button is not pressed, your data out should be equal to your operation. So it should be equal to the number you entered in your previous state. And then when you press the button, the data out should be equal to your result, which is the value you calculate based on your operation. And once that's done, you can go back to your S0 state. Here we have two examples. The first one is an addition example. We're going to do 6 plus 3. So in order to do this, first thing you do is enter 6 with the switches, and then you press the valid in button. And then you release it, and then in order to do addition, what do we do? Let's look. Addition is 1. So next, you should enter 1 here. Once you enter 1, you should press your valid in button again, and then release it. And then, in order to enter 3, you should enter 3, and then press valid in. And after you do this, you should see your result. The next example is a decrement by 2 operation. In here, you're going to take data in and enter 7 through your switches. You're going to press your valid button. And then, in order to decrement, let's see. So decrementing is 5. So you're going to enter 5 and then press valid in. And then your data out will be 5 because 7 minus 2 is 5. Next up, we're going to see the synthesis of the project. Here, I have created my project. Once I'm done, I'm going to synthesize the project. So I double click the synthesize project. Now you're going to get a couple warnings here. So we've had these warnings, the delay warnings in the previous labs, and we've already said that they are not important. But now we get a warning about an 8x8 multiplication. So when you do an 8x8 multiplication, 8-bit by 8-bit multiplication, what do you get? You should get a 16-bit result. But we are unable to display 16-bit results in our 8-bit LED display. So what we do is that we only look at the 8 least significant bits. So here the synthesizer is warning us about a overflow happening because you are putting a 16-bit value into a 8-bit register. So it's saying that the most significant 8 bits are going to be lost, and then we already know that, so this is not a problem. You can also ignore this problem. This is it for part 1. In part 2, we will see the simulation of the design.